let's go with the classes, right? Hi guys, welcome to NEET World Institute and NEET World YouTube channel. Yes, in this session we are going to concentrate on this topics. Yeah, I guess everyone is joining, right? Yeah, magnetism and matter. Okay, yeah, let me open the PPTs first. Okay. So wait for a minute guys, let me open the PPTs. Yeah. Yeah guys. So in today's class we are going to concentrate on this magnetism and matter, and when we talk about this chapter, no, this is in class 12th IPE, okay, and this is a very short answer questions which we are going to concentrate on this class. And the first question of this class is, what is the magnetic moment associated with a solenoid? So solenoid is nothing but when we take a ring, so n number of rings we are taking, no, it's from a solenoid, right? So the magnitude of a magnetic moment of a solenoid is, so we are talking about the turns of the rings, so the total number of turns, got it, 1 point. And when we talk about like turns, like the wires are there, no, so charges are passing, like when the charges are flowing, no, so magnetic moment or like the magnetic field takes place, obviously, right? So current will be there, right? The induced current we are talking in this and the cross sectional area, how much that area we are talking. So number of turns, current and area. So what is that area of the circle? Let me take that area of the circle. So area of the circle, no, when we talk about area of the circle, it is pi r square. So m is equals to n into I into a, n into I, this is pi r square, right? So this is the magnetic moment associated with solenoid. That's a simple question and it's 1 mark, I mean 2 mark answer, like one word answer, right? Got it? And the next question, if you see, the magnetic lines forms continuous closed loop. Why this forms a continuous closed loop? Since isolated magnetic pole does not exist, the magnetic lines forms a continuous closed loop. What is the meaning? What is the thing they are saying? Isolated magnetic pole does not exist. That's why the magnetic lines form a closed loop. Answer is isolated magnetic poles. Got it? And state Gauss law in magnetism. When we talk about Gauss law in electric charges and field, this is the formula, no? E dot ds is equals to q in by epsilon naught. So Gauss law, the number of flux passes through a closed loop is nothing but the total charge which is present in the inside the surface by the epsilon naught. The permittivity we are talking, right, epsilon naught, right? Similarly, when we talk about here, the net magnetic flux through any closed surface is always equals to 0. So sum of like integral integral of B dot ds, like a magnetic field into area. What is this ds? What is this ds? This is nothing but area. So magnetic field into area is equals to 0. Okay, this is the first 3 questions. You can take a look of this first 3 questions and we can go for the next questions. I guess done. We can go for the next questions. Can we go for the next questions, guys? It's a simple chapter. We can complete it easily. Like if you concentrate on this is for only for half an hour to 1 hour, you can complete this chapter. It's very easy chapter if you try to understand the things. I guess today is Feb 1, right? And hardly like only 2 to 3 weeks, like only 20 days are remaining we can take. So if you talk about that week off and weekends, everything, na, like you can remove that. I guess so you guys will chill, right? So if you remove like hardly 2 weeks is there, that's it. So try to prepare well. Don't like get distracted in any kind of things, okay? Like don't go for movies, playings, anything, okay? Sit and read only this one like 1 or 2 weeks. If you concentrate on this now, like your life will be happy, everyone says, but not like you will move to the next stage. That's the thing, that's the reality, okay? So try to focus on yourself. So whenever the thing is matter, please be focused. Yes, obviously everyone need to enjoy their life. So sometime we should enjoy, sometime we should compromise ourselves, right? Now done. Can we go for the next questions? Fine. So the next set of the questions, if you see, define magnetic declination. So declination in the term itself says like some angles are there, right? Na? So at a given place, the angle between the geographical meridian and the magnetic meridian, okay, the angle between geographical meridian and the magnetic meridian of Earth is called as magnetic declination. Okay, only 2 words you need to remember: geographical meridian and magnetic meridian. Got it? So next one, fifth question, define magnetic inclination or angle of dip. We have talked about declination. Now what about inclination, sir? Yes, it's one of the angle. So we will see that also. The angle of dip at a place is defined as the angle made by the direction. Okay, angle made by the direction, yeah, made by the direction of Earth's magnetic field with the horizontal direction in a magnetic meridian is called as and magnetic inclination. Okay, so sixth question, what they are saying, what happens to the compass needle at the Earth's pole? Like whenever like we are using the compass, right, it shows the deflection. Like if we turn like this, it is showing some deflection. If we turn like this, it will show some deflection, right? Like a north, south, east and west, like the deflection will take place, right? So here what is the working thing in the magnetic, the compass we will see. So compass needle does not work at the magnetic poles of the Earth, because at poles horizontal component Earth's magnetic field is 0, right? What is the thing they are asking? First of all, what happened to the compass needle at the Earth's pole? They are asking. In the Earth pole they are asking, right? So compass needle does not work at a magnetic poles of Earth because horizontal component of Earth's magnetic field is 0. Horizontal component of Earth magnetic field is 0. That's why, that's the thing happening here, okay, in the Earth's pole, right? So to what direction compass needle point at poles? To what direction they are asking, and which needle is to be used at poles? Fine. So compass needle can point to any direction, since horizontal component of Earth's magnetic field is negligible near the poles. That's the previous question also we have seen, like the field is 0 in the horizontal components, and the same thing when we talk about in the next question, like it is negligible near the poles they are telling, right? And what do you understand by the magnetization? Magnetization, right? So of sample, when a magnetic material is magnetized, the induced magnetic dipole moment per unit volume is known as intensity of magnetization. So intensity of magnetization is nothing but it is a magnetic dipole moment per unit volume, right? So that is the meaning of intensity of magnetization, right? You can take a look of this set of questions and we can go for the next questions. I guess done, completed. Yeah, so last two questions, okay, please concentrate on this last two questions. We can then wind up the classes. Okay, what are the units of magnetic moment, magnetic induction, magnetic field? Three things they are asking. One is magnetic moment, one is magnetic induction, one is magnetic field. So magnetic moment, it is nothing but, yes, it is A into m square, okay, A into m square, ampere meter square. Then magnetic induction, Newton per ampere meter, or let me take a pen, wait a minute. Magnetic induction, yes, so it's ampere meter square, Newton per ampere meter, that is magnetic induction. Or else we can say in terms of joules, that is joules ampere meter square, joules per ampere meter square. In terms of Weber, na, Weber per meter square. In terms of Tesla, it is 1 Tesla. Okay, 1 Tesla. That's the thing. Okay, understood. So magnetic induction, if you see, Newton per ampere meter square, joules per ampere meter square, Newton per ampere meter, joules per ampere meter square, then Weber per meter square, and then Tesla. Okay, Tesla. And finally the magnetic field, ampere per meter, got it? So three things: magnetic moment, ampere per meter square, magnetic induction, Newton per ampere meter, or else joules per ampere meter square, or else Weber per ampere meter square, or else Tesla. Then magnetic field, which is nothing but ampere per meter. Got it? So next is define magnetic susceptibility of a material. So ratio of magnetic of intensity, it's a ratio of magnetic of intensity of magnetization to the magnetic field is called as magnetic susceptibility. Okay, so which is denoted by zeta. We will say zeta is equals to I by H, okay, intensity, right, intensity, and magnetization to the magnetic field. So it's a scalar with no units and dimensions. It's a scalar with no units and dimension. So this is the questions of the this lesson, magnetism and matter. Got it? So yes guys, so with this we have completed this very short answer questions of this magnetism and matter. And let me tell you once again, whoever want the material of the IP class 11th and class 12th of any subject like physics, chemistry, math, 1A, 1B, 2A, 2B, botany, zoology, either it can be BPC or it can be MPC. If excuse me, yeah. So you need to do only one thing: download NEET World app and sign up and give a hi message in the chat box, and we will send you the soft copy material to you. Okay. So with this, I'll wind up the classes, guys, and thank you.